All right, let's talk about pure functions in functional programming versus impure. And yes, sometimes you just have to use impure functions anyways. Okay, what is a pure function? Given the same input, you must always get the same output. And also, no side effects, no modifying things outside of the func, like this. Okay, if I have a function add a and b, and it just returns a plus b, this is a pure function, right? Because if I pass in 1 and 2, I will always get 3, no matter what. This is a pure function. If I add in a console.log, this is now an impure function. Why? Because this function is just supposed to add things, but it's now reaching out to the global scope and calling the .log function, which is modifying a side effect because it's modifying our screen. It's printing something on the screen, right? Same thing if you do add event listener, or you do .text content and you're modifying things. All of those will make the function impure. Also, other things like if I have an array here, and then inside I do myar.pop, this is directly mutating an array that is outside of its function, right? So just because of that, this function is impure. Now, why do we even care about having pure functions? It's actually a lot harder to write pure functions than impure functions because you have to keep these two requirements in mind. For impure functions, you just do whatever you want, right? That's object-oriented programming. In functional programming, they like to keep it pure, so it's easier to debug, but also for function composition. So what is function composition? Function composition is when you write two or more pure functions, and then you compose those functions together to get a new result. So we have an array here. The sum is 6 and the average is 2. We're going to use pure functions and functional composition to get the average of this from one function. Okay, so let's break it down. We need to define our sum function first. So let's do function sum array, taking in an array. And we know that we can sum a basic array by using reduce. So I'll just keep it short, arr.reduce, taking in accumulator, init, and it returns accumulator plus init. All right, now let's do a function that finds the average. Okay, actually, we don't even need to do that. Let's just define a function that says divide and taking in two numbers, a and b, and it'll just return a divided by b. Okay, so far, both of these functions are pure functions. Okay, if you pass in this array into some array, you're always going to get 6 as the result. Same thing with divide. If you put 10 here and 5, the answer will always be 2. So now function find average, also taking in an array, but in here is where we're going to use functional composition. So first, I'll do const my sum will be equal to calling sum array right here and passing in the array argument. Okay. So after we have my sum, we can do const my average will be equal to what? We're going to call divide. But for the arguments, the first argument, we're going to pass in my sum. And the second argument, we need to know how many indexes or values in an array. We can just find that by doing ar.length. And then down here, we can return my average, like so. Okay, so if I copy this here, and I pass in a random array, we have the average. Okay, if we pass in our my ARR, we're expecting the answer to be 2, which is true. Okay. So here, we just did some functional programming. We defined 2 separate small yet pure functions, and then we compose them inside of a larger function. Now, the benefits of doing this is that if these are really complex functions and you need to change something or there's a bug, you can just go right into the function here and you can modify it. Because if you run find average and something goes wrong, it'll say like, oh, there's an error on line 20. And then you'll know right away, okay, line 20 is where I compose my sum array. So something's wrong with my sum array definition. I'm going to go in here and I'm going to fix it. Okay? Now, the con of functional programming, let's just say average. Okay, so now we can just call this function average. This is a sum, and then we can just literally divide by my AR.length. And then on the right here, if I call it, we get the same thing, right? But this, let's just say this average function is really complex and then there's an error or something. You're gonna have to look through thousands of lines of code because there's no other functions inside here. Yeah. So yeah, functional programming has its pros and also has its cons. And I wouldn't recommend anyone do functional programming until you're actually familiar with object-oriented programming. Because to me, OOP is what JavaScript was designed for. It wasn't designed for functional programming that much.